Let's talk about something you probably never think about: the road beneath your wheels. It's not just asphalt and paint, it's a battle between soil and weather. That dirt is the foundation. And if you get it wrong, you don't just get potholes, you get disasters. Before any construction starts, engineers have to understand the ground. Is it rock solid, or will it wash away in the next storm? Soil erodibility is the key, how easily the ground can be worn away. Weather is the wild card. Rain, heat, wind and ice can turn a project into a mess overnight. Building a road is like building a house. If the foundation is weak, everything falls apart. That's why engineers spend so much time testing the soil, poking, prodding and torturing it to reveal its secrets. It's dirty work, but it's the bedrock of safe roads. So next time you're driving, remember, there's an invisible battle happening under your tires. It's soil versus weather, with engineers making sure you don't end up in a sinkhole. Let's dig into how they test the ground and outsmart the elements. This is the real story behind every road you travel. What is soil erodibility? It's how easily soil gets worn away by water or wind. Imagine a sandcastle, one wave and it's gone. That's high erodibility. Clay in your backyard, spray it all day and it just gets muddy. That's low erodibility. Engineers can't guess. They need to know exactly how much abuse the soil can take. That's why they run tests, so they know if a storm will wash everything away. Water is the main culprit. The faster and heavier it flows, the more soil it can rip away. Clay soils stick together, resisting erosion. Sandy soils, not so much. They break apart easily. Knowing this helps engineers plan, plant grass, lay blankets, or build walls to keep soil in place. It's all about predicting trouble and stopping it before it starts. You don't wait for a landslide, you prevent it. Smart engineering starts with knowing your dirt. That's how you build roads that last. It's proactive, not reactive, and it all begins with understanding soil erodibility. Now let's get into the tests, starting with the pinhole test. This test checks if water can erode soil from the inside out, like through a tiny crack. Engineers pack a soil sample into a mold, poke a small hole, and run water through it. If the water comes out clear, the soil is tough. If it's cloudy, the soil is eroding. They also watch if the hole gets bigger. Bad news if it does. Based on this, soils are classified non-erodible or highly erodible. If it's erodible, engineers might treat it or avoid using it in critical spots. It's a simple test, but it can prevent disasters. The pinhole test tells you if the ground will hold up or fall apart. It's a small experiment with huge consequences. That's how you keep roads safe from the inside out. One tiny hole can reveal a world of trouble, and that's why this test matters. The jet erosion test, or JET, is like blasting the soil with a mini water cannon. It simulates what happens when water scours a roadside ditch or embankment. Engineers shoot a jet of water at a compacted soil sample and measure how quickly it erodes. They track how deep the hole gets over time. Two numbers matter: critical shear stress, the force needed to start erosion, and the erodibility coefficient, how fast it erodes. These numbers help engineers predict how a slope or channel will hold up in storms. If the soil erodes too fast, they reinforce it with concrete, fabric, or rocks. The jet takes the guesswork out. Engineers get hard data, not just hunches. It's all about building embankments and channels that last. With the jet, you know if your soil can take a beating or if it needs backup. That's how you outsmart erosion before it starts. Now, let's talk about rain, the biggest troublemaker on any job site. A downpour can turn a construction zone into a mud pit, halting work and costing money. But it's not just about delays. Rain can wash away exposed soil, sending sediment into rivers and causing environmental headaches. Crews have to install silt fences and basins to catch the runoff. Rain also messes with materials. Soil that's too wet can't be compacted right, leading to weak foundations. Sometimes crews have to wait days for things to dry. or use chemicals to speed it up. Even fresh asphalt is at risk. Rain can ruin a new pavement in minutes. That's why foremen watch the weather like hawks, timing every move. One wrong call, and thousands of dollars and hours of work are lost. Rain is more than an inconvenience. It's a force to be reckoned with. Rain isn't the only weather villain. Heat, cold, and wind can be just as tough. Extreme heat is brutal for workers and materials. Asphalt stays too soft, and concrete can crack if it dries too fast. Sometimes crews pour concrete at night just to avoid the heat. Cold weather? It's a project killer. Below 40°P, you can't pave or pour concrete. If water in the soil freezes, it expands and cracks the road, a disaster called frost heave. When it thaws, the ground turns to mush and the road collapses. Wind might seem minor, but it can blow dust, debris, and even ruin the application of materials. Strong winds can cool hot asphalt too quickly or blow away curing compounds. The perfect day for road building? Calm, dry, and mild. A rare thing. Every weather extreme means more delays, higher costs, and tougher decisions. That's why timing is everything in road construction. Weather isn't just a backdrop, it's a major player, and it never takes a day off. Timing is everything. Building in the dry season is every road builder's dream. Fewer rain delays mean a predictable schedule and better quality. Soil moisture is easier to control, so you get a stronger foundation. Paving is smoother, and you don't worry about storms ruining fresh work. But sometimes, you have no choice but to build in the wet season. That's when things get tough, muddy sites, stuck equipment, endless delays. Wet ground makes compaction nearly impossible without expensive fixes. Erosion is a constant threat, and costs skyrocket. Productivity drops, and you pay more for less work. Sometimes you need extra equipment or temporary roads just to keep moving. The risk of poor quality work goes way up. In short, dry season means control. Wet season means chaos. So why go through all this trouble for a strip of pavement? It's about safety and longevity. Roads are lifelines for communities and economies. Testing soil and respecting weather means roads that last and save money in the long run. It's cheaper to prevent problems than to fix disasters later. Smart planning and constant vigilance separate the pros from the amateurs. Every smooth, reliable road is the result of dirty, difficult, and smart work. The ground beneath your wheels is complex, and the weather above is powerful. By understanding both, engineers build the infrastructure that holds our world together. Next time you drive, remember the science and sweat behind the road. It's a dirty job, but we're all better off because someone does it.